Okay, so this time we've got a little bit of a different polynomial problem. We still want to find the zeros of our polynomial function and write it as the factor, the function as a product of its leading coefficient and its linear factor. So what is our leading coefficient? Well, in this case, our leading coefficient is 3. This is a 4th degree polynomial. Since it's not directly factorable, we have to go through some of our other means of finding polynomials. So let me just go through my zero finding routine. What I might note is that, of course, P of 0, the y-intercept, is -4, and we have a positive leading coefficient with an even degree, so we know that the graph tends towards negative infinity as positive infinity as x tends towards negative infinity, and y tends towards positive infinity when x tends towards positive infinity as well. So we know there has to be at least 2 x-intercepts somewhere in there, 2 real zeros here at a minimum. What did Descartes' rule of signs say? Well, by Descartes' rule of signs, we say that P of positive x has 1 sign change, 2 sign changes, 3 sign changes. So we say that we could either get 3 or 1 possible positive zero, and if we try P of negative x, right, P of negative x, I'll just do this in green, would mean that this first term stays positive, the second term turns positive, the third term stays positive, and the last term is negative. So that implies that there is going to be only 1 possible negative real zero. Well, we would have to get at least 1. All right, and then of course I might use my rational zeros test, because now I'm going to try and find my factors. I'm going to try and find my zeros. So we need a list of possibilities to check. In this case, it's actually relatively short. We would take factors of 4 over factors of 3. So plus or minus 1, 2, or 4 in the numerator, and 1 and 3 in the denominator. So our list looks to be positive or negative 1, positive or negative 2, positive or negative 4, positive or negative 1/3, positive or negative 4/3, and positive or negative 2/3. I know that's a little bit out of order, but I think my brain just did that to me. Okay, so what we're going to do is we're going to test to see if we've got any real zeros right here. I always start with the easiest numbers. Let's start with positive 1. Let's see what happens. If I put in positive 1, we've got a 4th degree polynomial, so we're going to have a 3. We're going to have negative 14. We're going to have 17. We need a placeholder for our 1st degree term. We're going to have negative 4 here at the end. So let's just continue on. So what do we do? Bring down the 3, multiply, add down the column, multiply, add down the column, multiply, add down the column, multiply, add down the column. Well, that's actually pretty useful, right? Because now we know that P of 1 is equal to 2. If you think about what's happening on this graph, well, it must be that we have a function that has a 0 somewhere between x equals 0, which has its point below the x-axis, and x equals 1, which has a point above the x-axis. So somewhere in between there, we've got a 0. So what do we have between 0? Well, we've got a choice of 1/3 or 2/3. So I'm going to skip ahead and I'm going to say, well, let's say I tried 1/3. I found that it didn't work. But what about 2/3? Does that work? Well, we can just try it out. 3, negative 14, 17, 0, and negative 4. It gives me 3. 2/3 of 3 is 2. Negative 14 plus 2 is negative 12. 2/3 of negative 12, let's see, 12 divided by 3 is 4, times 2, that's 8. So negative 8. 17 minus 8 is 9. 2/3 of 9 is 3 times 2, 6. 0 plus 6. 2/3 of 6 is 4. And lo and behold, there it is. We know that P of 2/3 is equal to 0. And the other thing that we've just found is that x minus 2/3 would be a 0, would be a factor. But now let's check something out. What does that mean if it's a factor? Well, that means that so far we've got P of x is equal to 3x cubed minus 12x squared plus 9x plus 6 times x minus 2/3. Notice that all of the factors that are left over here have 3 as a common factor. And by the way, that's our leading coefficient. We're left with x cubed minus 4x squared plus 3x plus 2. Any other factors that are left over are going to be factors of this polynomial right under here. So what could we do? Well, I'm only going to deal with this guy right here, and I'll note that my possible rational zeros list has changed. And my possible list of rational zeros no longer contains any zeros, no longer contains any, fractions. I only have positive or negative 1 or positive or negative 2. Right? And I've got a positive real 0, but I'm guaranteed of getting a negative real 0, so I'm going to jump over here and I'm going to say, well, what happens if I put in something like negative 1? Let's try it. And what I'm going to do is I'm going to use my reduced polynomial, so 1, negative 4, 3, and 2. Does that work? Well, bring down the 1, multiply by negative 1, that's negative 1. And that becomes negative 5. Negative 1 times negative 5 is positive 5. Plus 3, that's 8. Negative 1 times 8, that's negative 8. That gives me negative 6 as a result. Does that work? Well, it seems to, but unfortunately negative 1 is not a real 0 right here. What's going on? Right, and by the way, by the lower bound test, if you had talked about it, we'd say that there are no zeros less than negative 1, so what do? Well, we've tried positive 1, found that it's not a 0, so let's work our way out. Let's go out to positive 2 this time and see what happens. Well, if I try positive 2, 1, negative 4, 3, and positive 2, I bring down the 1. 2 times 1 is 2. Added, that gives me negative 2. This gives me multiplication negative 4. 3 and negative 4 is negative 1. 2 times negative 1 is negative 2. Hey, what do you know? We've got another 0. We now know that P of 2 is equal to 0. And what else have we found? Well, we've now found that P of x, when we factor it, will be equal to 3 times x squared minus 2x minus 1. Right? Remember, these are the coefficients for a third-degree polynomial, so you're dividing away a first-degree polynomial, leaving a second-degree polynomial. We'll have x minus 2 as one of the factors from that, and we'll have x minus 2/3 from before. Can we do anything else? Well, now we would have to find zeros of x squared minus 2x minus 1. So I'm going to set that equal to 0, and let's see what we can do. I guess what we're going to have to do is complete the square. So let's try that. X squared minus 2x will equal positive 1. complete the square, of course, I'm going to add 1 to both sides. And if I factor on the left, I get x minus 1 quantity squared is equal to 2. So if I take my square root, x minus 1 will equal positive or negative the square root of 2, which indicates that x is equal to 1 plus or minus the square root of 2. So in fact, we have 2 more zeros. Our zeros are x equals 1 plus the square root of 2. That's a positive real number, right? 1 plus 1.4142 something or other. And x equals 1 minus the square root of 2. And there's our negative number right here. 1 minus 1.4 something is less than 0. So that's a negative real 0. So if we get zeros that are not rational numbers, well, they're not going to be on this list. So we would say if this is our 0, we can treat this as x minus that number 1 plus the square root of 2. And that will become a linear factor. And if we subtract the other one, x minus the quantity 1 minus the square root of 2, right, that makes this second thing a linear factor. So our linear factored form of p of x in this case is going to be 3, the leading coefficient, times x minus 1 plus the square root of 2 times x minus the quantity 1 minus the square root of 2 times x minus 2 times x minus 2/3. This is exactly what we're looking for, the product of the leading coefficient and 4th degree linear factors multiplied together, and so we're done with this one.